So far in this course, we've covered all of the fundamental sketch tools. So in this lecture, I will highlight some additional sketching techniques to support us in 2D sketching. We will take a look at how to sketch construction lines and how they differ from generic lines. I'll introduce you to the measurement tool, show you how to switch between dimension diameters and radii, and we'll also take a look at the sketch palette. So construction lines, you might have seen this in previous lectures. These are construction lines here. They are dashed lines, and they can be used as temporary reference lines to help position and align other entities within a sketch. So essentially they act as guidelines that can be deleted once the primary design elements are placed. So I'll give an example of how these can be used. Let's come out of the Create tool and a slot. I'll do a center to center slot. I'll just throw this in anywhere. Give that any dimensions. And then I'm going to use my mirror tool, select these geometries, and under the mirror line, I can select, let's say this line here. And so this is a good example of where construction lines are used. It's used as a reference line, in this case to help us project a geometry by using the mirror pattern that's directly in the center of the two horizontal lines. So how do we input construction lines? Let's hit L on the keyboard. To put in construction lines, we need to ensure that the line type, so under the sketch palette, that this construction icon here is then highlighted like so. And then any geometries that I draw will be construction lines like so. Also the same likewise goes if I use other tools. So if I use the circle creation tool, okay, or if I use the rectangle tool. So it's important when we're finished with our construction lines to make sure that this is unchecked, like so. So how does that differ from generic lines? I'll show you the key difference here. So when I hover my mouse over this rectangle here, it's actually split into 4 rectangles. So these are 4 individual profiles. Whereas when we're using construction lines, the rectangle itself just acts as one profile. And this can be really handy when we later come to 3D modeling. If we're using the extrusion tool, revolve tool, sweep tool, loft tool, etc., we are required to define profiles in which to 3D model. And in this case, we would have 4 individual ones, whereas in this case, if we take out the slots, we would just have one profile available. If you did by accident draw any construction lines and you wanted to make that a generic line, you can left click on it, and then under the sketch palette, we can just uncheck the construction there. Okay, move that back, and there we have a generic line. And as you see now, we have these 2 profiles available. Another really useful tool we can use when sketching is the inspection tool. And that's located just under the toolbar here. So we can just click there, or under the drop down, it's the very first one. It's the shortcut I on the keyboard. If I hit I on the keyboard, they're going to take some measurements. So the toolbox pops up. We've got options here to select faces, edges, vertices. We've got bodies, which we'll be covering in the 3D modeling section, and also components. Under precision, I just leave that as the default. And if you want to measure in secondary units as well, you can do so. So let's take a look at that in a bit. So for now, I'm going to select this horizontal line, okay, which is identified as selection 1, and then this vertical line identified as selection 2. And immediately, Fusion will show us the angle between those 2 lines. And if we look in our toolbox, we'll see that selection 1, so the horizontal line, has a length of 200 mil, and selection 2, the vertical line, has a length of 125. So let's take a look at secondary units then. Let's say we wanted to measure in imperial units, so inches. We now have a look at the length. It's shown in metric, and then in brackets afterwards, shown in inches. So 7.874 inches is 200 mil. Let's give another example of that. I'm going to hit I on the keyboard again. I'm going to take a measurement this time from the center point of this circle to the corner point of this rectangle here. Now, if we look at our toolbox, you can see quite a bit more data there. So we've got this results section. So the true distance between the 2 is 71.589 millimeters. We've got that in inches as well. And then if we want to see the distances on the X, Y, and Z axis, we can select one of these. So for example, if I select this one, we can see that on the Y, we've got 15 mil, on the X is 70. And we can switch between the measurements being aligned to section 1 or 2. So for example, I've got them as 1 here, or as 2 there. So those figures that we see on the screen are then input here. So X, Y, and Z. Then we've got some more data down here. So selection 1, which is the center point of this circle, its position relative to the origin is 300 mil, on the Y 0, and then on the Z 95. So we can see the two axes up here. We've got the X and then the Z there. And the same for selection 2, X, Y, and Z. So referencing again from the origin 0, 0, 0 on the X, Y, and Z axis. So that's a very handy tool for quick measurements. We don't have to input dimensions. We can just do a quick check there on either distances or angles. And the last tool, or rather technique, that I want to show you in this lecture is how to switch between diameter and radius when we're dimensioning off circles. I'm going to hit C on the keyboard. I draw in a circle there. Let's go for 100 mil. So we've got our 100 mil diameter circle here. Now this is currently displaying as a diameter, but we can change it to a radius. You simply right click on it and select toggle radius, and then you'll see it will become radius measuring 50 mil. A nice quick tip to finish this lecture. And I hope those tips were useful and you'll be seeing me use these throughout the course. And I look forward to seeing you in the next lecture.